Hello everyone. So in this video we are going to talk about Liskov Substitution Principle. It is the most important principle which is being asked in every interview that I have faced, and it states that the object of superclass should be replaceable with the object of subclass without affecting the correctness of the program. What does it mean is the object of superclass. That means let's say superclass is vehicle. So object of vehicle should be replaced with the object of subclass. Subclass, let's say car. So object of vehicle should be replaced with object of car, and it should not affect the correctness of the program. So do not worry about this. We'll see this particular thing with the help of example and everything. Just bear with me. Now let's come to the technical definition to have more clarity on it. The technical definition is, let phi x be a property provable about object x of type T. Then phi y should be true for object y of type S, where S is subtype of T. Now again, it's a very complicated statement. Bear with me for 2-3 minutes and I'll explain you what it actually means. What is phi x is just a function, nothing else. Okay. And what it states that it is a provable property of x. Here we can say property of behavior. It's a provable property of x. And what is x? X is of type T. What is phi y? Provable property of y. And y is of type S. And this should hold true if S is a subtype of T. Okay. Again, this will be a little complicated to understand. Let me explain it with you in an example and it will be very clear to you. Okay, so understand this point, that this should particular hold true if S, that is Y's type, is a subset of X's type. Okay, and what is X and Y? X is nothing but the object of T and Y is nothing but the object of S. Okay, now let's say, let X be vehicle's object. Okay, and what is T here? T is nothing but a vehicle. So X's type is vehicle. So let's say X is vehicle's object. Let's say it's have a behavior move. That is, vehicle should move. Like whenever we'll call move, the vehicle would be moving. Also, it has a behavior that is provide seat to passengers. So it should have a seat on which passengers could sit. And what is X's type? X's type is nothing but a vehicle. X is an instance. Instance means vehicle's object. Okay. So now the other part, the subclass part we are talking about. So Y is car's object, and what is Y type? It's car. Okay. And phi Y should be provable property of car, that is move and provide seat to passengers. Okay. So car also moves and it provides seats to the passenger. So both the cases can be satisfied with the vehicle. Also, car is a subtype of vehicle. Okay, so car can always stand in for vehicle. Okay, so you can say that car is a vehicle and whatever the methods that is there is also satisfied on car as well. And by definition is subclass can always stand in for base class. Here LSP is satisfied. LSP is Liskov Substitution Principle. Here we can say that okay, LSP is satisfied because all the behavior that a vehicle has, the car also has the same behavior. Okay, car might have additional behaviors, but the generic vehicle, whatever behavior it has, the car also has the same behavior. So here LSP is satisfied. Now let's come to a negative example where X is bird, and what bird can do? It can eat and it can fly. Okay, so now let's take Y as ostrich. Ostrich is also a bird, and phi Y is nothing but the property of ostrich. So can ostrich eat? Yes. But can ostrich fly? No, it cannot fly. So ostrich cannot stand in for bird. Obviously ostrich is a bird only, But whatever methods we are defining in bird, ostrich cannot satisfy to all the methods because it cannot fly. No, ostrich can always stand in for bird. No. So LSP is unsatisfied here. So what should be the case here? How to make it LSP compatible? Now let's see, we have interface or abstract class which is bird. What is the function of bird? To eat. Okay, that is all that we can define here. Then there are flight birds and there are flightless birds. Okay, so with flight birds, we can say flight birds is also a type of bird. Okay, what it can additionally do is cover long distance in air. So what flight birds would do if they have to cover a long distance, they would not use their legs to cover the long distance. They would fly instead and cover the long distance. What flightless birds can do? Obviously, it is extending the bird. So flightless birds will also be eating. And how they are going to cover the long distance? So they are going to cover the long distance on ground only. They'll not fly and then they will cover the distance. Now let's create the real object. For example, let's take a parrot. What is a parrot? Is parrot a bird? Yes. Is parrot a flightless bird or a flight bird? It's a flight bird. So what we are going to do, we are going to implement flight bird. And then we have to provide body for the abstract methods. That is, cover long distance in air and eat. So now you can see that I have completed this function that cover long distance in air. That is covering long distance in air, and for eat, so I am a flight bird who is eating right now. So similarly, we are going to create ostrich also. And is it a flight bird or a flightless bird? It's a flightless bird. And what happens if it implements a flight bird? Now if we implement by mistake that ostrich with flight bird, then we might have to give body to cover long distance in air. And here we had to throw exception actually. Now if by mistake you implement the flight bird here, then you might have to provide body to cover long distance in air. And can ostrich fly? And can it cover long distance in air? No, of course not. So you might have to throw exception here. This is a runtime exception, that unsupported operation exception, that ostrich cannot fly. Okay, and this is the issue here. We do not want any runtime exception at prod. Okay, so here LSP is not satisfied. But instead, if you have the flightless bird, then this is not required. And we might have to provide body to cover long distance on ground, which we can do. Which we can do. Okay, here we do not have to throw any exception. Hope you get my point, what we are trying to do. And can base class stand in for superclass? Yes. Let me write bird, bird, new, ostrich. Yes, there is no error. If I call bird dot eat, there is only one function. So I'll not be able to call any other function. Doesn't have fly function, which will give a runtime exception. Okay, and similarly for flight birds also, can I give flight bird as an ostrich? No, we cannot give, because ostrich is not a subclass of flight bird. What we can give here? We can give parrot. What parrot can do? Parrot can eat, definitely, that's coming from bird interface. And what parrot can do? It can cover long distance in air also. So you see, for ostrich we got the output, I'm a flightless bird who is eating right now. And for flight bird, I'm a flight bird who is eating right now. Instead of it, should give it a. So this is the output that I'm getting, that I am an ostrich who is eating right now, because we called the bird.eat function. And for flight bird, we gave a parrot object. So we can call both the function, eat and cover long distance in air, for which we are getting the output, I am a parrot who is eating right now and covering long distance in air. I hope you understand my point. Here LSP is satisfied because the subclass can stand in for superclass. Here also parrot can stand in for bird class and ostrich can stand in for bird class. Okay, so parrot can stand in for bird, parrot can stand in for flight birds. Similarly, ostrich can stand in for bird and ostrich can stand in for flightless birds also. That is it guys. Hope you are enjoying my videos. I'll see you in the next video with integration segregation principle. Thanks.